On the topic of inverse hyperbolic functions. Hyperbolic sine and hyperbolic tangent are one-to-one function, and so they have inverse functions that we denote by inverse hyperbolic sine and inverse hyperbolic tangent. Remember that the behavior of hyperbolic cosine was like a parabola, so in general, it's not one-to-one on its domain, but you can restrict the domain to 0 and positive infinity, and it becomes a one-to-one function. The inverse hyperbolic cosine function is defined as the inverse of this restricted function on the right-hand side. You can take left-hand side as well. No one's stopping you. So y is equal to inverse hyperbolic sine. It means that sine of y is equal to x. This is hyperbolic sine. The same if you define y equals to inverse hyperbolic cosine. What's the meaning of that? It means that hyperbolic cosine of y is equal to x. And please note that we take positive part. If y is equal to inverse hyperbolic tangent, it means that hyperbolic tangent of y is equal to x. So remember that the rate of change of hyperbolic cosine or the derivative of hyperbolic cosine has a different formula. The derivative of hyperbolic cosine was equal to hyperbolic sine. But when we are defining the inverse functions, the derivatives behave differently. The rate of change or the derivative of inverse hyperbolic cosine of x is 1 divided by square root of x squared minus 1. And please note that x is positive. The derivative of inverse hyperbolic sine is in turn defined as 1 divided by square root of x squared plus 1. The rate of change of inverse hyperbolic tangent is defined as 1 over 1 minus x squared, and absolute value of x is less than 1. The rate of change of inverse hyperbolic cotangent is 1 over 1 minus x squared, and absolute value of x is more than 1. We can in turn find the rate of change of inverse hyperbolic secant, which is negative 1 divided by x times square root of 1 minus x squared. X is bounded between 0 and 1. And finally, the rate of change or the derivative or the differential of inverse hyperbolic cosecant is negative 1 over absolute value of x times square root of 1 plus x squared. Why these are important? Because sometimes you end up with the quantity like this inside your integral, and it's good to know that they have a definition. So you already have the antiderivative. So you can easily calculate the integral using the inverse hyperbolic functions. So in general, if you have the integral of du divided by square root of a squared plus u squared, this in turn is equal to inverse hyperbolic sine of u divided by a. Don't forget the constant of integration in indefinite form. And a must be positive. 2. The integral of du divided by square root of u squared minus a squared is inverse hyperbolic cosine of u divided by a plus c. In this case, both u and a are positive and u is more than a. Number 3, the integral of du divided by a squared minus u squared has 2 cases. If u squared is less than a squared, then you end up with inverse hyperbolic tangent. However, if u squared is more than a squared, you end up with inverse hyperbolic cotangent. Number 4, the integral of du divided by u times square root of a squared minus u squared is negative 1 over a times inverse hyperbolic secant of u divided by a plus c, and u is bounded between 0 and a. And the last one is the integral of du divided by u times square root of a squared plus u squared, which is negative 1 over a, inverse hyperbolic cosecant of absolute value of u over a plus c. U is non-zero and a is positive. Let's take a look at an example. So far, we learned that the integral of du divided by square root of a squared plus u squared is inverse hyperbolic sine of u divided by a. So if I ask you to evaluate the following integral, this is the definite integral 0 to 3 of dx divided by square root of x squared plus 16. The definite integral 0 to 3 of dx divided by square root of x squared plus 16 is by definition inverse hyperbolic sine of x divided by 4, because here you have x squared plus a squared is 16, a is 4, and x ranges between 0 and 3. This guy can be written as inverse hyperbolic sine of 3 over 4 minus inverse hyperbolic sine of 0. Hyperbolic sine of 0 is equal to 0. So you end up with inverse hyperbolic sine of 3 over 4. You can use a calculator and simplify this, or you can use the definition of inverse hyperbolic sine of x, which is ln of x plus square root of x squared plus 1. Remember that all of these functions, hyperbolic sine, hyperbolic cosine, and so on, we used exponential function to define them. So when you're taking the inverse of them, you can write them in terms of ln or other types of functions that are inverse of exponential functions. So inverse hyperbolic sine of 3 over 4 is ln of 3 over 4 plus square root of 3 over 4 squared plus 1. If you simplify this, you get ln of 2. So the result of this integral is equal to ln of 2, or if you use a calculator, you get 0.693.